So now that we're out in the tree past the Gentianales, the first thing to do is to note that nearly all the remaining eudicots are aligned with either the superrosids or the superasterids. The one possible exception is the Lamiales, shown here as a gratuitous bit of trivia because it's too obscure to pass my inclusion criterion. In the APG III, the Lamiales isn't placed within either of the main arms of the eudicots, but I suspect that this will change in future revisions. By the way, here's a picture of Dilenia. It's a tropical plant. And so for now, the APG has very conservatively put these guys on a branch off the base of the tree, while I've seen them also put a couple of points further out in the tree by different workers. So anyways, here's the picture of the core eudicots. So you'll have a clearer picture of what I mean when I talk about this branch or that branch. Dilenia and Gunnera are part of the core eudicots, but at least for now we're not putting them into either the superasterids or the superrosids. Each of these limbs splits into two major branches again. The superasterids splits into the Lamiids, and this is the group that we're going to be following in this video, and the campanulids. And down here the superrosids will split into the fabids and the malvids. And we'll be getting to all these other ones. We'll be getting to the campanulids and the fabids and the malvids in a future video. So while this layout depicts all these groups as being roughly the same size, which is close enough to being correct, it doesn't really give me enough room to detail the Lamiids like I really want to. So here I've redrawn the tree to de-emphasize the parts we cover later. Superrosids are down here, fabids and malvids. Campanulids are over here. No details are going to be put on them in this tree. And I'm doing this in order to make enough space to cover those groups, the Lamiids, on which we'll be spending our time in this video. Now there are two asterid orders down here, Caryophyllales and Ericales, that are basal to the splits between the Lamiids and the campanulids. So we're going to start with them, and after that we'll head into the Lamiid half of the asterids, also known as the Asterid 1 group, from which I've selected these four orders to address. So the Caryophyllales is a rather messy order. And by messy, I mean mostly that the internal organization of the families is not especially well resolved as of the APG III. Moreover, it's really not even 100% clear that the Caryophyllales belongs within the asterids at all. It might actually be part of the rosids, and I could actually see the Caryophyllales swinging back and forth between the rosid group and the asterid group a few times over the next 10 years as we get more data. The Caryophyllales is also a very large plant order with 35 families, most of which we're not going to name. Now there are two thematic patterns clustering families within the Caryophyllales. One of them is carnivory and the other is succulents. There are a few other families that are neither carnivorous nor succulent that we'll be bringing up because they have important plants, ornamental or food plants, in their membership. So the Caryophyllales has one cluster of family that are all noted carnivores. They eat bugs because this is how they're able to meet their nitrogen needs in habitats like bogs that are notoriously nitrogen poor. The best known of these families is the Droseraceae, which contains the Venus flytrap plants and the sundew plants. There's also the Nepenthaceae, which are Southeast Asian pitcher plants, ecologically very similar to the North American pitcher plants and cobra lilies, which actually belong to a different family and order. We talk about them later. Also very significant within the Caryophyllales is the Cactaceae, the family of succulent plants of which all forms of true cactus belong. True cactuses are typically stem succulent, which means that the leaves are very much reduced or modified into spines, while the stem has become a water storage structure whose surface is the primary photosynthetic tissue, as opposed to the leaves, where most other plants conduct their photosynthesis. The other very commonly encountered family of succulent caryophylls is the Azoaceae, which includes the ice plants and jade plants, as well as tiny succulents like this Conophytum. And all of these are leaf succulent plants, storing water and photosynthesizing in the leaves. That is quite differently from the succulent strategy used by cacti. Now, not all Azoaceae are succulent. Galeenias, for example, are non-succulent versions of ice plants. They're in the Azoaceae, and they're popular in drought-resistant landscaping. They sort of look a whole lot like ice plants, but without the succulent leaves. You can walk on them without getting your shoes all slimy. Now, as far as edible Caryophyllales go, cacti should be included. After all, these prickly pear cactuses up here is the source for Mexican treats like the nopales. The pads are called nopales, and the fruits are called tunas, and they're delicious. But in addition to the cactuses, we also have edible versions of caryophylls. In fact, a lot of our veggies, beets, Swiss chard, spinach, quinoa, are all part of the family Amaranthaceae. And then there's also the Boraginales that gives us buckwheat, shown down below. There are other Caryophyllales families that you encounter regularly as ornamental plants, and usually it's for the flowers. The order gets its name from the carnation family, or the Caryophyllaceae, which is sometimes called the pink family, but not because of the color. Pinking actually refers to the zigzag edge that you find on the outside of the petals. If you don't believe me, look it up. The Boraginales contains several plants that are frequently used in landscaping, like plumbago, this guy over here. We have lots of it on our Oceanside campus. Sometimes we call it leadwort because of the lead-colored flowers. And statice in the genus Limonium. The Nyctaginaceae includes bougainvillea, another non-native that's popular in landscaping, as well as mirabilis, sometimes called the 4 o'clock, which is basically another pretty flower used in landscaping and in floral arrangements. Now, when it comes to the habit and growth form of the Caryophyllales, they're sort of all over the place. And by now, you should probably expect me to try to dig up some kind of unifying trait that we might use to distinguish the Caryophyllales from the rest of the eudicots. Now, I can't always promise to have good, easy-to-use synapomorphies, but in this case, there are a couple of notable characters for discussion, even though they might not be very useful for field identification. First, most plants have chlorophyll, of course, which is lipid-soluble or oil-soluble green pigment. But they also typically have red to purple water-soluble pigments. You know, for example, that green pigment doesn't leach into the water when you boil spinach. Maybe it leaches a little bit, but not the same way that the red or purple color leaches into the water when you boil a red cabbage. Okay. For red cabbages and for the majority of plants, the red pigment is anthocyanin, this molecule. In the Caryophyllales, however, there's no anthocyanin at all, and this role of water-soluble red pigment is covered by a different kind of chemical, betalain, which is the red color found in beets, and Swiss chard, and red amaranth, and most of the Caryophyllales. The one exception to this rule, oddly enough, is the Caryophyllaceae. It's the one family in the order that has anthocyanin instead of betalain. Another relatively good order-wide phenomenon in the Caryophyllales is almost a stunning lack of association with endomycorrhizal fungi. Let me write that down. Okay, so the endomycorrhizae are a very special sort of soil fungus in the fungal phylum Glomeromycota, and they make their living by interacting with the soil and also with many kinds of plant roots, sometimes mediating between the roots and the soil. Most plants form associations with glomeromycetes, forming these mycorrhizal connections that are often beneficial to the plants. Caryophyllales, on the other hand, are really notable for being characteristically non-mycoheterotrophic and shunning any interaction with these potential soil symbionts. Most plants, mycoheterotrophic. Caryophyllales, not so much. So there you have the Caryophyllales of our abbreviated survey. And as I said before, we might be seeing this order relocating to the superrosate clade. This would not surprise me at all. We might just as easily be seeing its position within the Asterid clade more firmly supported. Now the next plant order is the Ericales, for which the evidence aligning it with the Asterids is much stronger, to the point where it would surprise a whole lot of people if in the future evidence were shown to reposition it somewhere else in the eudicot tree. Now the Ericales probably is basal to the Lamid campanulid split. And out of its 23 families, I've got a much shorter list of mention-worthy families to cover. So the Ericales also has a family of carnivorous plants. the Sarraceniaceae, which contains the pitcher plants and the cobra lilies found in the low nitrogen boggy habits in North America. Now there's a temptation to classify these guys together with the Nepenthes type pitcher plants that we saw earlier, but the two are not closely related, with each evolving their trap structures independently of each other due to the similar selective pressures but in two different continents. There are quite a few families in the Ericales that have edible members. There's the Actinidiaceae, to which kiwi fruit belong, those fuzzy green fruit that also grow on plants with fuzzy leaves and fuzzy stems. And then there's the Eboniaceae, which contains both the tree that gives us ebony wood used for guitar fingerboards and the black piano keys. But also in the Eboniaceae, there's Diospyros kaki, persimmon, a tasty fruit that might not be familiar to everybody, but it's actually pretty widely known and appreciated, and it can be found in farmers markets, if not in supermarkets in the fall season. Over here we've got some modern persimmon fruits, and up at the top we've got an Eocene version of Diospyros. Pretty much the same tree, only from a much different era. And again, those are in the Eboniaceae. Next family is the Ericaceae, or heath family, in which you've got cranberries, blueberries, huckleberries, as well as many ornamental plants like azaleas and the rhododendron. And then there's the Teaceae, or the tea family, which includes all forms of camellias, including the tea plant. And yes, tea leaves that you use to make tea come from a camellia bush, as well as all the other ornamental forms of camellia. Now I included another edible family that you might not be familiar with. It's the Sapotaceae, which is the family that gives us some of the fruits that are commonly known as sapotes. Specifically the mamey sapote, which you're seeing here, as well as the sapodilla, which I've seen in Latin America, but not so much here in the United States. Now, if you're familiar with these fruits, you should take note that there's another fruit called the sapote, the white sapote, which is actually in the Rutaceae. It's a different family in a different order. And so you have to be kind of very specific about which sapote we're talking about. Now, as far as other kinds of familiar, though not edible Ericales go, we've already talked about ebony, wood, azaleas, rhododendrons, and camellias. But there are a couple of other families that are notable to those living in Southern California. One is the Fucariaceae, the family of the ocotillo plant, which is a spiny plant native to the southwestern deserts. We see these on our outings at the local deserts with students in our natural science club. And then there's the Polemoniaceae, or the phlox family. It's frequently encountered among the wildflowers of Southern California, and in fact our state is a diversity epicenter for this family. One of the easy ways to tell the Polemoniaceae, if you look at the pistil of the flower, the style comes up and it splits into three. You've got this tripartite style. 2, 3. And that's a characteristic of the Polemoniaceae. The Primulaceae, or primrose family, contains some easy to recognize wildflowers, like this shooting star, Dodecatheon, with its characteristic back-swept petals. Also in this family is Ericales, the scarlet pimpernel, which is a really common weed that I find in my garden all the time. Now, order-wide common characteristics of the Ericales are again on the slim side. Most plants have 5-petaled flowers, and a lot of them have petals that are fused into a tube or a cup-like structure. Now you should be warned that not all of the Ericales are going to have this. Scarlet pimpernel, for example, does not have fused petals, and fused petals is also a characteristic seen in many other plant orders. Another trait that makes this group the exact opposite to the Caryophyllales is the way that the Ericales plants do form strong endomycorrhizal associations. Their roots interact with specific soil fungi, and there are even some parasitic plants like Sarcodes, sometimes called the snowflower, that parasitizes other plants by connecting to them through the filaments of the soil fungi. This is a plant that doesn't even need chlorophyll. It's a holoparasite, meaning that it takes all of its photostimulants from a different host plant, probably a nearby tree, again through the fungal filaments. And that takes care of our second basal order, the Ericales. Now the remainder of the asterids are split, or they're divided between the Lamiid group, or the Asterid 1 clade, and the campanulid group, or the Asterid 2 clade. We're going to be talking about 4 of the Lamiid orders: the Gentianales, the Solanales, the Boraginales, and the Lamiales. The Gentianales is to me a misleading order name because I think of gentians in the family Gentianaceae as nice little plants that I sometimes see in meadows. This is a pic of a little gentian that I found on a mountain trail. But in the big scheme of things, I can't think of gentians as being a very important plant family at all. If plant orders were named after the members that are most important to humans, this order would probably be called the Coffeeales, because Coffea arabica, the coffee plant, is in this order in the family of the Rubiaceae, which is sometimes called the coffee family or the madder family. Other kinds of rubiaceous plants include the cinchona, which is the source of quinine used in antimalarial drugs, as well as in tonic water. And there are also quite a few ornamental plants that are in the Rubiaceae as well, like gardenias. For this survey, the 2 significant families within the Gentianales are the Rubiaceae and the Aposinaceae, or the dogbane family. And it might actually be best for us to talk about these 2 families together, as they're most notable. And in fact, this is actually true for the entire Gentianales, but these 2 families in particular are the only ones we're naming. They're notable for their production of these chemicals called alkaloids. The historical context is one involving coevolution with insect herbivores. Now, plants evolved to produce toxic chemicals, which had the effect of deterring herbivores. But some of the herbivores, probably insects, evolved to tolerate the plant toxins, and this put selective pressure on the plants to become even more toxic, with both larger quantities of toxins and more potent toxins. Now, some of the herbivores were able to respond by evolving to tolerate the higher degree of toxicity. And over thousands of generations, there's a chemical arms race that goes on. These more toxin-resistant insects are putting additional pressures on the plants to evolve greater and greater levels of toxicity. And over thousands of generations of this evolutionary chemical arms race, plants generally, but particularly so in the Gentianales, have come to possess a large diversity of potent alkaloids, which is a class of nitrogen-containing organic compounds that's associated with both toxic as well as pharmacological properties. The connection of toxin with medicine might sound kind of strange, but it makes sense if you think about it. If a plant produces a chemical that has a negative effect on the physiology of the insects that would otherwise eat the plant, it would stand to reason that those same chemicals are likely to also have an effect on the physiology of other animals, like humans. Now, most times those effects are going to be toxic, but sometimes, and in carefully administered dosages, those chemicals could have therapeutic effects. Humans make use of these chemicals in various ways. Poisoning one's enemies is just one of these ways. Now remember, in the years 2011 and 2012, there were a couple of very high-profile murders involving Gentianales-derived alkaloids. Strychnine, a long-used active ingredient in rat poisons, is extracted from the seeds of Strychnos nux vomica, which is also in the Gentianales. Now, alkaloids are also very important parts of our arsenal of medications for a variety of conditions. We've already mentioned caffeine and quinine, which are Rubiaceae-produced alkaloids, but many other kinds of drugs, and I'm talking about real drugs here, not things used in the homeopathic nonsense that some people believe in. Many real drugs are the natural products from plants. Now, a favorite example of this are the vinca alkaloids, vinblastine and vincristine, which are isolated from Catharanthus roseus, the Madagascar periwinkle in the Aposinaceae. These alkaloids have turned Hodgkin's lymphoma, which is a kind of white blood cell cancer, from what used to be a death sentence into a nearly 100% curable cancer. Now, there are several kinds of alkaloids that are used as recreational drugs, like opiates and cocaine, but those are produced by plants from different orders. Well, one of the psychoactive components in ayahuasca comes from the chacruna or psychotria plants native to the places where ayahuasca is used. That's kind of exotic though, and it may be that caffeine is really the only important recreational drug produced by the Gentianales. Okay, so back to naming a few of the more familiar plants in the Apocynaceae. Sure, it could be that every leaf is effectively an elaborate chemistry laboratory, but this family is also known for its purely ornamental members, including Plumeria, whose flowers are in the leis that greet every visitor to Hawaii, as well as pretty flowering vines like the Mandevilla and Petopentia plants that grow along my fence. How do I identify a plant in the Gentianales? These plants tend to have opposite leaves. That means that there are two leaves at each node coming off on opposite sides of the same stem. Now in the Gentianales there's also a characteristic line that comes across the node right between the two leaves. And if we're talking about the Apocynaceae, many of these have a milky sap. In fact, this close-up of the Petopentia shows all three of these characteristics. You've got the opposite leaves, you've got this line right across the stem where the two leaves are attaching at the node, and I broke off a little leaf here to show the milky sap that oozes out. Okay. These tricks, opposite leaves, line across the stem, milky sap, is a trick that I learned for recognizing Apocynaceae a long time ago. It's an old school method that still works. So that's the Gentianales. The Solanales is another Asterid 1 order of great importance to humans, largely because of the Solanaceae, or nightshade family, which is another prolific producer of alkaloid compounds. This is actually an elaborate tree showing 1,000 species that are all members of the Solanaceae. Now, one of its best known members is Nicotiana tabacum. It's a nightshade that produces a highly addictive alkaloid, nicotine. Recognize it by its Latin name? This is tobacco. The Atropina is the group containing Atropa belladonna, also known as deadly nightshade, another solanaceous plant whose leaves and berries are horrifically toxic. Then you've also got the legendarily poisonous plant, Datura, and Mandragora, also prominent members of the family Solanaceae. Now nested within this family, together with all these deadly plants, are tomatoes, peppers, eggplants, tomatillos, all things that I grow every summer in my vegetable garden. I don't grow potatoes, but there are also solanums, as are a large diversity of plants that are popular in simple landscaping, like petunias. The Convolvulaceae, or morning glory family, is another very familiar member of the Solanales, both for the above-ground flowering parts of the plant, as well as the tasty storage roots that they tend to have, those things that we call sweet potatoes. Now within the Solanales, there's a large range of plants and sizes, ranging from tiny herbs to small trees, and as well there's a large amount of variation in leaf shape. For me, I still kind of rely on the old school trick of looking for a fused calyx, sepals that instead of being separate, they fuse into a cone-shaped structure, as well as a fused corolla. Petals are similarly fused into a cone or a tube. Now, there are plenty of other kinds of plants that do this. They have tubular flowers, like the Rubiaceae that we see over here, and the Nicotiana tabacum that we see over here. 3 plants, 3 different families, and yet all of them have that characteristic tubular or cone-shaped flower. What I'm telling you here is don't put too much weight into this, but again, it works often enough for it to be a useful characteristic. So there you have the Solanales. Now the third order that we're naming within the Asterids 1, or the Lamiid clade, is the Boraginales, which is really small in comparison with the other orders in this video. I'm including it mostly because they're among the very common spring annual natives in our part of Southern California. And they're also really easy to identify, so it's kind of fun. So if you come across a small plant with a flower cluster in an unfurling coil, kind of like a scorpion tail or a violin headpiece, like this, right? Then it's probably going to be one of 3 genera. If the flowers are blue or purple, it's Phacelia in the family Hydrophyllaceae. If it's white, then it's most likely going to be a cryptantha in the Boraginaceae. And if the flowers are yellow, then it's going to be Emsynchia, also in the Boraginaceae. Apart from a little aesthetic and little native knowledge, there's no other huge significance for this group. So there you have the Boraginales. And the last order within this clade that we're going to discuss is the Lamiales, which is the order that the Lamiids are named for. It's another large plant order, including 25 families and a large range of different plant forms. Earlier in this video, we learned about Sarcodes, the parasitic ericaceous plant that draws nutrients through mycorrhizal fungi. The Orobanchaceae of the Lamiales is a family of largely hemiparasitic plants that are common among California wildflowers. The Indian paintbrush, shown here, is Castanea. It's actually one of two forms of Castanea, and there's a set of several species of Castanea that are all forms of Indian paintbrush. The owl's clover is another Castanea. And this genus, together with the majority of the Orobanchaceae, are hemiparasites, making direct connections with their roots to the roots of host plants using structures called hostoria, and they draw water and nutrients away from the host plant to supplement the Orobanchaceous plant's own photosynthesis. Now, the fact that these plants do at least some of their own photosynthesis is what makes them hemiparasites as opposed to the holoparasitic plant that derives almost all of its resources from its hosts. So the Lamiaceae, or mint family, is a family of all mints, sages, basils, rosemarys, lavenders, marjorams, zaatars, perias. You get the idea. The list goes on. Lots of fragrant herbs. The Lamiaceae members are usually pretty easy to identify by their opposite leaves, squared stems, whorled inflorescences. You can see in this cluster of flowers, or the inflorescence, that the flowers are packed like a little wheel that goes all the way around. That's called a whorl, as well as frequently being fragrant. Like in a lot of the bigger, messier plant orders we've been talking about, it's easier to learn and recognize the families of the Lamiales individually rather than trying to find something in common holding all the members of the order together. Here, the Lamiaceae is one of the easy-to-identify plant families. The other important food member of the Lamiales is the Oleaceae, or olive family, from which we get olives as well as ornamental trees and shrubs like privets and lilacs. Ash trees as well. Its wood is the one that's used to make Major League Baseball bats. It's in the Oleaceae. Now this is an olive branch, and you can see the opposite positioning of the leaves, which actually happens to be something held in common by most, if not all, members of the Lamiales. I'm just going to do a quick run-through of the other frequently encountered members of this order, pointing out families that are either common as Southern California natives or as ornamental or landscaping plants. So the Acanthaceae has a large variety of genera of plants that you might recognize. Too many to give a halfway complete list, so I'll just pick out a few. Now, one of the native plants in the coastal sage scrub is a small bush with tubular red flowers. It's hard to miss. It's called Chuparosa. And this is Justicia californica. And so there are also a lot of non-native Justicias used in landscaping. This one, for example, is a Justicia that happens to have orange flowers. There's also Thunbergia, which is a vine producing orange flowers. One type shown here is called a black-eyed Susan, and the other one that does not have the black spots is called the orange clock vine. The Bignoniaceae is the family containing the non-native jacaranda trees common in Southern California that produce shows of lavender blossoms on city streets throughout the Southland in June and July. This Bignonia is a vine that's coming over into my yard from the neighbor's yard, and it has these characteristic flowers. It's very commonly used in landscaping. The Gesneriaceae includes the African violets of the genus St. Paulia. It's a popular houseplant with fuzzy leaves. Not much else. The Phrymaceae is the family to which another one of our coastal sage scrub flowers belongs. The monkey flower, or Diplacus, is an orange to red flowered small bush, often with sticky leaves. It's very common along hiking trails in Southern California. Diplacus is closely related to a popular ornamental flower that you might be familiar with called Mimulus. The Plantaginaceae include snapdragons in the genus Antirrhinum, which are popular bedding plants as well as an important model organism in plant studies. The Verbinaceae is the family containing the limonene-imbued lemon verbena, as well as ornamental verbenas, sometimes called vervains. Another plant in the Verbinaceae is the lantana, which is popular in butterfly gardens. Lantana is also a highly invasive plant, threatening natives in many parts of the world, including southern India, where it's kind of growing rampant. And that completes our survey of the Lamiales. In this video, we cruised quickly through some of the highlight taxa within the basal asterids, Caryophyllales and the Ericales, and also the Asterid 1 or Lamiid clade of the Asterid eudicots, from which I selected to feature the Gentianales, the Solanales, the Boraginales, and the Lamiales. In the next video, we'll look at the Asterid 2 clade, also known as the campanulids among the superasterids.